All right. So we got this other projectile launch. This time I want to dial it up a notch because that was too easy.
No.
Yeah, that was too easy. Now I want to talk about somebody who launches something off of a cliff, but not horizontally. So, got this person sitting here. Let's just say something simple like they throw a ball off a cliff. That's fine. But if I throw a ball off of a cliff, I'm going to have to think about what angle they launch this ball at relative to the horizontal. So here's my horizontal. And I mean, this is more general because most things don't get launched perfectly horizontally. But if I launch this thing off at an angle, we said previously that all of our projectile information is listed relative to a horizontal in terms of its direction. So I want to launch it off at 20 degrees. And the way that I would read that is 20 degrees above horizontal. Okay, so I'm launching at 20 degrees above horizontal. I'm going to say that I've got a V1, an initial launch velocity of 11.5 meters per second. And as I draw this diagram functions as my givens. So those people that are resistant to drawing diagrams, get into it. Start drawing your diagrams. It says that the cliff itself is 25 meters tall. So I'll measure that out. 25.0 meters. And I'll give myself a reference frame. It's actually going to be a similar reference frame, but I've got up, down. I'll call it right and left. I say similar because since I'm launching this one upwards initially, I think I'm going to make a switch. I'm going to decide, since it is going up initially, I'll call up positive and down negative, but I'll still call right positive and left negative because it is going to be going towards the right. And by default, the very first thing that I should do when I approach these kinds of questions, because I'm not even going to look at what the question is first, by default, what we should all do when we have an angled velocity is right away find its x component and its y component. Okay? So what I mean by that is, if I have a velocity that looks like this, we've been talking about components the past few days. So I've got my V1. V1 is going to have an x component, V1x, and it'll have a y component, V1y, such that V1y is equal to V1. Look, there's a theta here. V1 times sine of theta is equal to, looks like it's 11.5 meters per second times sine 20 degrees. V1x is going to be V1 times cos theta, or 11.5 meters per second times cos 20 degrees. And I do a little bit of math on this one, and I say, okay, well the y component is going to be 3.9. And can you guys check me? I can hear the calculator buttons. Make sure I got this. Does that look right for the y components? I thought I heard a calculator button. Yes, no? Anybody? And then for the x component, I get 10.81 meters per second. Both of those are positive because they're to the right and up. But can I get a little confirmation? Are they correct values? All right. Thanks, Zoe. Appreciate it. All right. So that was my default thing. My other default thing is to take inventory of what I know in the x direction and the y direction.
Mason, keep your hands off me.
Okay? Gentlemen? Thanks. So V1x is going to be 10.81 meters per second. Acceleration x is 0. We said that's always going to be the case for these projectiles because gravity doesn't operate in the horizontally. We say our inventory in the y direction, V1y is equal to, we just calculated it, 3.9332 meters per second, and acceleration y is, oh, remember, we said down is negative, so it's negative 9.81 meters per second squared this time. And this is all my autopilot framing of the question. I haven't even looked at the question yet, okay? I know the scenario, I know my givens. Part A says, what amount of time does it take to return to its original height? Well, I have an object that's going through the air, and it's going up, and it's coming back down again. So I actually just want to sketch out, what the heck does that even mean? Here's my cliff. I got a ball that starts in the person's hands. It launches up, it goes up, it comes back down again. But the question says, how much time does it take to return to its original height? Well, that's all the way back here. Well, I guess it's down a little bit from there. But it returns to its original height. That's what it means to return to its original height. And say, okay, well, if that happens, I can add on a little bit of extra givens. Displacement in the y direction would be 0. When it gets here, it has been displaced 0 in the y direction. I know it's traveled in the x direction, but it hasn't gone anywhere in the y direction. It's back to its original height. What I want to know is the time. I say, okay, well then in the y direction, I now know v1y, I know ay, I know delta dy, and I want to know time. That's my new inventory that I know for the y information. And I go and I find myself an equation of motion that kind of suits that. I go shopping through my equations of motion, and I say, well, delta dy equals v1y delta t plus 1/2 ay delta t squared. That actually fits the bill. I mean, look at this. Delta dy, that's 0. Boom. I know v1y doesn't equal 0. I know acceleration y doesn't equal 0. I know that I can't zero anything else out. But as I look at this, I say, hey, wait a minute. If I write this as 0 equals v1y delta t plus 1/2 ay delta t squared, can you guys see that there's a delta t on both of those terms? My math hat comes on, and I say I could factor out a delta t. Out of that binomial, v1y plus 1/2 ay delta t. Remember, I factored out a delta t, so that delta t squared becomes just a delta t. And I say, okay, well, that expression equals 0. Well, again, my math hat comes out, and when I have a binomial like this, either this binomial equals 0, because 0 times anything is 0, or the time equals 0. The time equaling 0 is what we would call the trivial answer, because that's silly. Look, yeah, of course the displacement in the y direction is going to be equal to 0 when you haven't left yet. That's what it would mean to be time equals 0. And so the other answer, the other route, if you're that kind of person, is to say, hey, we should be looking for the solution to this binomial being equal to 0. So I say, okay, I can do that. I'll say v1y plus 1/2 ay delta t equals 0 then. Again, I'm using my basic math skills, and I'm using it in the context of physics, right? And I'm trying to find out what that time value is. All right, so I'm going to take over the v1y over to the other side. I get 1/2 ay delta t equals negative v1y. I can multiply both sides by 2 and divide both sides by delta t. I'm going to do both of those steps in one go, and I'm going to say that means that delta t is going to be equal to 2 times that negative v1y divided by the ay. And I'm ready to just sub in some values. I think I'm going to just put my equal sign beside there because I don't want to run out of space. Don't tell my math teacher friends that I did it. Bad form. 2 times negative v1y, so negative of 3.9332 meters per second, divided by ay, which was negative 9.81 meters per second squared. And always in that, like, that's one of those situations. See how the negatives are going to cancel out? Which is good because time shouldn't be negative, right? We want to have a positive time. And we end up saying, okay, well, seems to me, can somebody with a calculator help me? How long is this going to be in the air for? Because I don't trust my numbers from last time I jotted this down. I think it's going to start with an 8. 0.8 something.
Oh, okay.
Yep. 0.80, what was it? 1876, okay. Seconds. So not even a second to get back to its original height. And we could have a rounded value. We could say, okay, well, it's delta t equals approximately, I guess it was 3 significant figures, so approximately 0.802 seconds. And I've run out of space for a therefore statement, but it would be about 0.802 seconds. And the follow-up question is, find its maximum height. Find the maximum height of the ball. And if we're going to look at the maximum height of the ball, we're talking about, if I was in math class, I might be thinking about a vertex here, right? And if I said the word vertex, everybody knows what I'm talking about? The tippy top, right? So if I were to draw a diagram, I always like to re-illustrate this to reframe what I'm trying to think about. If I say this ball goes up, and it comes back down again, thinking about this like a vertex, as soon as I draw it this way, people are like, oh yeah, vertex, oh yes, y-intercept, oh yes, x-intercept. It's all coming back. And so there's some commonality, there's some familiar language going on here, but we're talking about how high is this ball off the ground? Remember, that means how high is it above where it started, plus how tall the cliff is. That's how high it is. So we're not in math class, we're in physics class, so we're not going to use the word vertex really, but that's what we're talking about when we say how high. Now we're also saying that when we started this thing, we started at position A, and we're trying to get to position B, just so that we all are talking the same language here. And the cliff hasn't changed. The cliff is still 25.0 meters tall. And I think to myself, is this Y thinking or X thinking? You guys tell me. Y. Yeah, this is Y thinking. And I always think, is it Y thinking or X thinking? Because that's going to let me know which list of inventory to draw from. Okay, so I got to think to myself, okay, delta dy, that's what I'm looking for. V1y. I'm just redrafting my inventory just so I can keep it all in one place. I don't want to lose track of anything. V1y is 3.9332 meters per second. That's starting at what I call point A. V2y. We saw this with a kangaroo once before. What's V2y going to be? Yeah? 0, yeah. That's actually a nice thing to know. 0. It would have been nice to know when we were trying to figure out that kangaroo problem, right? Acceleration in the y direction is going to be, we call down negative, 9.81 meters per second squared. We know a lot. Hey, we actually know how much time has gone by? People look at a situation like this, and if you were to reflect back at this cartoon here, and you were to say, hey, I could make use of symmetry. If I said I could make use of symmetry, can you see that if I know the flight time to get to this height, half that flight time would be the time to get to the max height? I can be tricky like that, right? Remember, just because you didn't learn in math class, just because you're logicking it out, doesn't mean it's not fair, right? This is fair game. I can make use of symmetry. That's allowed in this class, right? So we say, okay, well, the time to get, you know what, I'll call it the time to get to the maximum height. I'll just call it delta t max, just for lack of a better name, is going to be delta t, and I don't have a better name, so I'll just call it delta t same height. That's a ridiculous subscript, but it's kind of descriptive for me, divided by 2. And so I can say, okay, well, I did that once before, 0.801876 seconds divided by 2. That's going to be the delta t same height. 0.801876 divided by 2. Oops. And I get 0.400938 seconds it takes to go from where I started to what I labeled as point B, capital B there, right? And I think, well, I got a lot of information. I actually have more information than I need. So I get to be creative about how I'm going to solve this thing. And I think this time, even though I do know the flight time to point B, I think I'm not going to use it this time. I'm just throwing it out there that maybe that would be something you would do, right? So I think I want to do something else. I think I want to say v2y squared equals v1y squared plus 2ay delta dy. And the reason that I would do that is because it looks like I know v2y is 0. I know v1y is that value there. I know ay is negative 9.81. This seems fairly cut and dry. This seems fairly straightforward. So I'd isolate to get delta dy all by itself. And I'm getting pretty good at this. I can do a lot of it in my head. And as I do this in my head, I get v2y squared minus v1y squared divided by the 2ay. Now, if you can't do that in your head, I would suggest that you try to do a little bit more of it in your homework. And if you feel like you can't do it in your head and you're not being successful, it's okay to show every step, okay? So I've taken away v1y from both sides, and then I divided both sides by 2ay. Sub it in our values. Oh, sweet, v2y is 0. So I always do that whenever I can. So that now I can just sub in negative v1y is negative 3.9332 meters per second divided by 2 times negative 9.81 meters per second squared. Look at that, the negatives are going to cancel out, so that's convenient. And I get it 0.78848 meters. Still less than a meter. Oh, you're right. The answer's correct, but I forgot to write down that it's squared. Thank you for calling me on that. But the negative signs do still take care of each other. And so that's up. And I look at this and I think, like, oh, wait a minute. This less than a meter, is that the maximum height, or do I have to do something? What do I got to do? Add it to 25, because that's how much I've gone up by, right? That's the little bit that I added back there in this cartoon. So I got to make sense of my numbers. So I'd say, well, I'm just going to call it h max, because I don't know what kind of variable to call this thing, and that seems like something people should be able to figure out. Is going to be delta dy plus the height of the cliff. That seems like something that people should be able to figure out. So when I don't have a specific variable, sometimes I just try to be descriptive, because I want the reader to know. 0.78848 meters plus the height of the cliff, which was 25.0 meters. And I know that in math class people might talk about like how high is the vertex above the y-intercept, right? This is a question that could pop up. But notice that all that stuff you're doing in math class, it's transferable skills, right? We've got a lot of transferable skills here, and so I'm just drawing attention to that, okay? So I'm not going to talk anymore after this about vertex and y-intercept and x-intercept, but you're going to recognize that we're calculating roots, we're calculating max heights, we're doing all this sort of thing that's overlapping. Anyway, we get 25.7884 meters. And I think, oh shucks, this was straight up addition, isn't it just a 1 decimal place? So I got to round this off nicely to 25.8 meters. Maximum height above the ground is 25.8 meters. So therefore, the maximum height was 25.8 meters above the ground. Part C. What's the total flight time of the ball? Again, I want to sketch this out because I want to have a picture of what the heck the question's asking. Total flight time, remember we started off at point A before. Fly through the air. Last time we stopped at B to figure out the maximum height. Previous to that we figured out how long it takes to get back to the original height. Now we're going all the way to the bottom. Smack it into the ground. Total flight time. Now, I do still want to hold on to some things. I'd like to call this guy position B, because maybe I'll come back to that. And I'd like to talk about this guy's position C, because that's where I want to end up. I know that in the previous question we talked about getting up to the maximum height. And I want to take a look at inventory. Again, if I'm looking at maximum flight time, this is Y thinking. How long I get to be in the air for depends on how long I'm in the air before I smack into the ground. So that really is vertical thinking. And I say, okay, well, if that's the case, V1Y is still going to be equal to, well, wait a minute. don't I already know how long it takes to get from A to B? You know what I think? I think I'm going to accept that I know how to do that already. And I'm going to steal from part A. And I think I'm going to make this easy on myself. I think I'm just going to find how long it takes to get from point B to point C. And if I can do that, can't I just add that to the time it takes to get from A to B? That's what I'm going to do. All right? So I'm just going from B to C right now. I've highlighted in pink the path that I'm going to take. And so when I say V1y, what I mean is, what's the velocity at point B? You see what I mean? All right, so right here. There's this other thing that people talk about. They talk about symmetry. You know, V1 at position A was up. V1 at position B is down. What do you suppose probably is the relationship between the velocity at A and velocity at B? Yeah?
They're the same, but like opposite directions.
Yeah, it turns out they're the same magnitude, but opposite directions. So I'm going to make a claim, and this is a symmetry claim. The claim is that at point B it's going down, but just as fast as it was going up at point A. Okay? And that's a symmetry. Some people call it an anti-symmetry claim, but that's what it is. Okay? So a V1y is going to be negative 332 meters per second. V2y, and when I say V2y, I mean at position C. I don't know that value. I know acceleration y is equal to negative 9.81 meters per second squared. I know delta dy, look, from point B to point C, isn't it negative 25 meters? Is the height of the cliff, right? Negative 25.0 meters. The amount of time between I'll just call it delta t subscript BC. The amount of time between points B and C is something I don't know, and it's something I'd like to know. And there's a couple ways I could get at this. I could get at it using a quadratic, but I think I want to do a little cheat. I think that if I find V2y first, even though I'm not asked for it, V2y is equal to, V2y squared is equal to V1y squared plus 2ay delta dy. I could use that to get V2y equals V1y squared is the negative 3.9332 meters per second. Square that value. Notice that the negative sign is going to square and become positive. Plus 2 times negative 9.81 meters per second squared times delta dy, so negative 25.0 meters. And look, negative 9.81 times negative 25, that's going to turn into a positive as well, right? And so we end up being okay with everything inside of that square root being positive. Otherwise, we'd be in a bit of a panic. And we end up getting, at least I end up getting, 22.49377 meters per second. Now, anytime you square root something, you got to deal with the plus or minus. In this case, when it hits the ground, is it a negative or the positive? It's the negative. That's important because it'll impact the math later. I got to put that negative there. I know it's either negative or positive because of how square roots work, but the fact that it's going down means that I got to choose it as the negative. That's the admissible answer there. They call the right one the admissible one. That's the one that's allowed. Negative 22.49 meters per second. Now the reason I calculated that, even though it didn't really ask me for it, is because now, if I know acceleration y is equal to v2y minus v1y divided by delta t, that's just acceleration equals delta v over delta t. I can solve for delta t by rearranging and subbing in. And by doing this as a two-equation method, I get to sidestep using the quadratic formula because I still feel afraid of it. That's okay. We'll get over it. Okay? So if you had some quadratic trauma, v2y is going to be the negative 22.49377 meters per second minus v1y. So the minus is from the formula, but then there's another negative from the direction, 3.9332 meters per second. All of that divided by negative 9.81 meters per second squared. And we get a travel time of 1.89200 seconds. Now remember, that travel time is actually the travel time between point B and C. So what do I have to do here to get the total flight time? Yeah,
Add A and B up and B and C.
got it, yeah. So I could say delta t total equals delta t, I'll call it AB, but it was from part A of our problem, plus delta t BC. And we had 0.801876 seconds plus 1.89200 seconds. And somebody with a calculator, can you help me out? It's like 2.6 something or other. Does it end up being about 2.694? Help the fella out. Ray, did you get it? No? You got it?
2.69887.
2.69888. Whew, all right. Seconds, or approximately, oh my goodness, 2.70 seconds flight time. And I've run out of space for a therefore statement.